Hello friends, this is Shang Rafraina, and in this video I'll be providing a brief demonstration on the data mining tool SAS Enterprise Miner. So as you all can see, this is the SAS Enterprise Miner workbench running on cloud. To save time, I've already created the process flow diagram here, and I've already also created a project of data_mining. So to start with, initially we have to first upload a dataset. So the dataset I'll be using is a bank dataset containing client details used by a Portuguese bank in their direct campaigning initiative. To import the dataset, from the samples tab I've chosen the file import component, and from the properties I provided the path of my dataset. So now that I can also edit the variables or the attribute values in my dataset. So here is a role column which tells whether my attribute is an input variable or a target variable. I can also change it to some other role as well. The levels basically is the interval for numerical values and nominal for the categorical values. Here y is my target variable and it has nominal values of yes and no. Then by drop column we can either drop any of the column which find insignificant for our analysis by clicking here. Then we have a stat explore component. Stat explore component is basically used for providing the statistical details of the attributes in a data set. As you can see here, the chi-square plot. Chi-square plot basically tells the goodness of fit between the expected and the observed values of the variables here. Then we have a variable worth plot here, which basically tells that which of the variable is very worthful in our data set. Here duration is the most worth variable. In the output window, we basically see that we have the details of the attributes that we have. We have rows column, number of levels, and we also have a missing column which tells that whether the value of the column is missing or not. We also have a mode column, which, as we all know, mode basically is the maximum occurring frequency of a particular value. So for contact, we have cellular as the most repeated value in our data set. Now we have a multiplot component here. Multiplot component is basically used for providing a slideshow of graphs and charts of all the attributes against the target variable y. You all can see here is the job by y target variable job is our attribute. These different types of jobs on the x-axis, and they are plotted against the values of y. Legends are provided here, no for blue and yes for red. Next we have a data partition component, which is basically used for partitioning the data into the training, validation and testing set, which in our case is 50, 20 and 30. Then we have a control point, which is basically used for providing dividing the output to multiple outflows or taking multiple outflows into as a single input. So now we have two different data mining techniques that we'll be using: decision tree and neural networks. First we'll be discussing decision trees. So to start with, in the properties I had changed the maximum depth from 2 to 10, which means my decision tree will run up to 10 generations, and the leaf size is by default 5, which means the number of training rules that it has in that it will be having in its leaf node. Let's check the results. We can see the cumulative lift. We have the fit statistics, which has the average squared error here, which basically is for train, validation and test set, and other details are also provided. We can also go and check the visualization of the decision tree, which is the first split made on duration, making it the most important attribute in our data set. This is the root node. The between nodes are the decision nodes. The terminal nodes are the leaf nodes. Here, as you can see, there are different colors here. So the lighter the color means the less significant node it is, and the more darker the color means the most significant node has been created here, and it is basically the goodness of node decided by it. In view, we can go to model, node rules, and here we can basically check we can see the if then else conditions with which the tree can be created, basically the textual format of decision tree. Now we can also go to the output window of decision tree, and here we can see basically the tree leaf report, where we have the depths as 3, 2 and so on. So you can see that the depths are not in sequential order because the pruning of tree has already taken place, and this is basically the classification table of true, positive, false, negative here. Let's go to neural network here. On the left side of the properties in the networks, I have chosen the multi-layer perceptron as an architecture, and I have changed the number of hidden layer from 3 to 5. Now in the optimization, to tune it, I have chosen the training technique of backprop, which is backward propagation, and maximum iteration is set to 50. Now in tuning, I have the two parameters, learning rate and momentum. Learning rate basically means the adjustment of weights that can be done at the time of the execution of the model. So this is the value that has been provided. It should be as high as possible. Momentum is basically it should be as low as possible for a particular neural network. Now let's check the results here. Now as you can see here, the iteration plot, in iteration plot it took 31 iterations total out of 50 to get the best results out. In the fit statistics we can see the root square average, square errors for training, validation and testing, etc. In the output we'll see that there are total of 5 hidden layers: HL1, HL2, HL4, HL3, fifth one being here HL5, as I had taken the number of hidden layers as 5 instead of 3. Then we can directly jump on to the classification table. The classification table is here: false negative, true negative, false positive, true positive values. Now we have provided this output to control point to merge it, and then this output will be provided to the model comparison component, which will basically tell us which of the model is better. This can be found in the assess tab here. So in the model comparison you see that the tree model performs better as based on selection criteria. It has a lower misclassification rate than neural network. Now I have also used a reporter component here, which is found in the utility tab, and reporter component basically provides you a document in the form of PDF or RTF which has all the details of this diagram. Let's check it. Click on the view option and we see that this diagram is on the first page. See all the lift curves and cumulative lifts found here. Then this is the decision tree that we discussed. Then there are neural network statistics here, and below there is the model comparison that we discussed, that tree is better, and it is better because the selection criteria was misclassification rate, and every detail is provided here, as you can see. So this is a brilliant feature that is being provided by SAS Enterprise Miner. So that is all from my end. Thanks a lot viewers for watching.